everyone. A number between 100 through 999 inclusive, that means including 100 and 999, is chosen at random. What's the probability that it contains no zeros and at least one zero? That's your first problem. And our second one, we're doing the same thing, and we're going to do no nines and at least one nine. So the first thing we need to do is find our total. And you're going to just subtract, and you get 899, but you always have to add 1. So there's a total of 900. That means you're counting the first number. So your total is 900. And let me go over this real quick. If I said we're doing 3 through 5, and if you subtract it, 5 minus 3, you get 2. But technically, there's actually 3 numbers. So that's why you're adding 1, because when you subtract, you're losing 1. So always add 1 when you're subtracting to find the total numbers when it's inclusive. All right, so there's your total numbers. Now, when you're talking about 3 digits, so we're doing 1, 2, 3 digits. So there's only 9 ways to choose the first one. And because remember, your digits go 1, 2, 3, 4, 5, 6, 7, 8, and 9. So basically, we can't use 0. So there's only 9 possible ways. So that's going to be 9 times 9 times 9. Okay, so that equals 729 3-digit numbers with no zeros. All right. Therefore, the probability of no zeros is at 729 divided by your total. That reduces to 81 divided by 100. All right. And to do the probability of at least 1, all you're going to do is subtract from 1. So this is no zeros. So the probability of at least 1 0, that means everything but no zeros. So you're just taking 1 minus the probability of no zeros. So that's 1 minus 81 divided by 100. I'm going to go ahead and change this 1 to 100 divided by 100 because that equals 1. And that gives you 19 divided by 100. Now we're going to do the same thing. You might want to try this one on your own and pause and do that. So basically we subtract. So 9, this should be 999. 9,999 minus 1,000 equals 8,999, and you add 1. So basically there's 9,000 total numbers. All right. Now, what's the probability that it contains no 9? So just like we did before, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 to choose from. We have 4 digits, so it's 1, 2, 3, 4. And it can't be 9, so really we only have this many. So only have 9 possible choices. However, you can't have 0 the first choice, because that would only give you a 3 digits. So for the first choice, you only have 8. And then for the rest, you have 9. So that's 8 times 9 times 9 times 9, which equals 5,832 numbers that contains no 9s. So that is no 9s. That's your total for no 9s. All right. Now, so we want the probability of no 9's. Then you just do your parts to whole. So that's going to be 5,832 divided by 9,000. That equals 81 divided by 125 when you reduce it. And again, at least 1 9. That means we can't have the no 9. So it means everything but the no 9's. So the probability of at least 1 9, let me just write that out, 9, at least 1 9 is 1 minus the probability of no 9's. All right, so that's going to be 1 minus 81 divided by 125. And again, what I like to do is change this 1 to 125, or just use a calculator. But 125 divided by 125, and I'm going to subtract and put it over here. And that's going to give you 44 divided by 125. And that's it. Thank you. Have a nice day. Bye-bye.